Today on CodeDependent, we're going to talk about another demo that comes from my book, Flex for Fun. Last time we talked about a reflection technique of using bitmap image in a container and then reflecting that image below it to get a very simple reflection technique that didn't actually look that good. And the reason is because there is no perfect reflection in the real world. Right? So if we run that demo again, we can look at that. The upon reflection demo, we look at it, it looks okay. The reflection is obviously not a mirror copy because we put some translucency in there. But in the real world, you wouldn't see the full extent of the image. And also you wouldn't see it as crisp. Even though it's translucent, still the details are just as crisp in the reflection as they are in the image above it. So we can certainly do better than that. So let's take a look at this other version of it upon further reflection. So let's run this demo and see what we get. So in this version, we still have a reflection, but notice how the reflection just dies out. This is the way it works in the real world, where you have these matte surfaces, and there is no perfect mirror in the real world. And so you have these matte surfaces that reflect the light in all kinds of directions, and so the further away you get from the original image, the more it dissipates over time and over distance until you just don't even see the reflection at all. So how can we get that effect? And then how can we also get this sort of blurred out effect to make the reflection more realistic, again, because of the matte surface details of this thing that we're reflecting off of. So we use the same basic approach as we did last time. We have our main application that has this beautiful gray gradient in the background, and then it says, okay, I want everything sitting in my reflection container. Okay, here's the source of the image, and here's the dimensions of the image, and here's how to position it in my application container. And then we can take a look at the container itself. Again, this looks a lot like what we saw before. In the previous example, we have the source of the image and then the dimensions, the width and the height of the image for actually sizing in the container. And then we have the original bitmap image, and this is just positioning that thing that we see, the original image up here. And then the reflection is created similarly to what it was before, where we have a scale Y factor that just mirrors it. It flips it below the image, and everything is sitting in this V group object, so they're automatically stacked. We have the original image and then the flipped version below it. But then we mask it. This is the real trick, where we say, okay, I'm going to have an alpha mask, and here's the mask tag for my bitmap image that defines what's going on. And inside here we have a group that holds a rectangle, and the rectangle has a fill that uses a linear gradient. And what's going on in the linear gradient is where normally, so the gradient in the background of the application, for instance, that's drawing from dark gray to light gray to get that sort of gray gradient effect here. Well, the gradient that we're using in the reflection image is actually an alpha gradient. It's going to determine how much of the color beneath the mask is going to bleed through, and that depends on the values of the gradient itself and the opacity value. So we have a gradient entry with a completely opaque alpha, and then at a ratio of 0.4, so 40% of the way down, we have an alpha of 0. This means that the image is going to bleed completely through at the top, and then steadily going down to 40% of the way through, it's going to bleed through less and less until it just stops bleeding through at all. So we get that effect where it goes down in the reflection, and then by the time we get 40% of the way through the reflection, it's dissipated to absolutely nothing at all. So there are some other things that we can do to make the image more realistic besides just the dissipation of the reflection over time. In particular, we can blur the image out. So notice in the previous example, we had this perfect reflection. Even though it's translucent, we get all the details there. Well, what we really want is a sort of diffuse look of the image where everything's a little blurred out because there is no perfect reflection, right? The concrete details should not be there if it's reflecting upon any surface that's not a perfect mirror. And so to get that, we can simply use a blur filter, which comes with Flex and Flash for free. So we have this blur filter defined up above, up here. So we have a quality of 2. We're going to make it a little bit smoother, smooth out some of the sort of linear artifacts that you can get from the default blur. We are blurring by 5 in the X and Y direction. And then we're assigning that as the filter on the bitmap image of the reflection itself. So there are two main things to get that better reflection. One is that we apply a mask that's going to be an alpha mask so that we dissipate the reflection over time until it sort of stops showing through at all at some point. And we picked 40% as the arbitrary value for that. And then we also have this blur filter applied to make sure that the reflection has more of a diffuse, blurry look to it. And the result is this. And it's nice in and of itself. The point of this application was simply to show the technique. But this is actually done for a larger demo, which showed off a few different filter effects that I'll show here. So here's the reflection technique being applied here, and then as you select on different images, you can see the reflection being applied to each one of these images as it comes in. It gives it a nice sort of very rich and three-dimensional aspect to the application where the thumbnails are in front and the image is positioned somewhere behind with that reflection off that nice diffuse surface. If you want to see the code for this application and other related applications, check out my blog at graphics-geek.blogspot.com.